Hello everyone, wishing you all a very good morning. I hope all of you are safe, fine, healthy. Good morning, Vaini. Good morning, Janu. Please send your message on the ID with the name of Aztec. Good morning, 3007. I've logged in by two IDs. Good morning, Goli. One is Aztec Udenia, the other one is Aztec. So you have to send any message on chat. Good morning, Santosh. Send it on the ID, simply Aztec. That ID does not have any speaker, does not have any camera. Good morning, 3010. Just add your name with your good morning, Charita, with your roll number. That would be good, right? Becomes easier for me to recognize you. Very hard for me to recognize you in terms of your numbers. Fine, I'm fine. How are you, beta? Okay. Mm, good morning, Sai Sada. How are you, beta? Great, Vaini. Good to know that you are doing good. Take good care of yourselves. Uh, as you can see, weather is constantly changing, so you might get some fever, cold, cough. Save yourself. Don't take unnecessary risks that you have to. Stay at your home and study, because this is the time that you got to study. Okay. On that note, let me start with today's class. What we were doing in the last one? I think we were solving questions on Newton's second law of motion. We were trying to solve questions on Newton's second law of motion. We have seen what are the steps we need to follow. What we are going to do today is continue on our journey and see how we can solve questions using Newton's second law of motion, F is equal to ma. Let us start with the first question. The question will be simple in the beginning, and then as we go ahead, oops, what happened? And as we go ahead, we'll keep on changing the intensity of the question. So this is a block of mass 5 kg. What I have done here is I've applied a force of 10 Newton on this block at an angle of 37 degrees. And on this side, I've applied a force of 4 Newtons. So this is the question. Obviously, this track is frictionless. Friction will come later on. We have to find the normal reaction force and the force with which ground is pushing it, and the acceleration of the block. So these are the two things that you need to find out. The reaction force, in this case it is normal reaction because friction is not there, and the acceleration of the block. You have 2 minutes to do this, and I'll wait for you. So have you all tried the question? Do we have answers here? Normal is 50. That is not correct. You have not done it correctly. Do not jump onto answers. As I always keep on telling you, what is important at this point in time is the process, that you do the process correctly. Are you trying or shall I do it? Normal is 6. That is also not correct. Finally, but jumping on to conclusions too soon. Okay, what I'll do is, I'll do it. And hope that you can do the next one that comes. What is the first step? Draw a sketch. Sketch is there. Second step, isolate all bodies. There's only one body, nothing to isolate. Step number 3, draw free body diagram. Two forces are already there, 4 Newton and 10 Newton. They're already there. I draw the rest of the forces. One is gravity acting downwards, mg, 5 into 10. One is normal reaction, n, coming upwards. All the forces are there. What next? Next step, choose suitable axis. What would be my axis here? One axis would be vertical like this, y. One axis would be horizontal like this, x. Now resolve all forces along the given axis. This force is along y, no need to resolve. This force is along y, no need to resolve. This force is along x, no need to resolve. There is one force which is not along x or y, it is going like this. I need to resolve it. This 10 newtons, I need to resolve it. The two components. This one, this is 10, this is 37. So this becomes, the horizontal side becomes 10 cos 37. Cos 37 is 4 by 5. So this becomes 8 Newton. 10 into 4 by 5. And this becomes 10 sine 37. Sine 37 is 3 by 5. 10 into 3 by 5. This becomes 6 Newton. Now once you have done this, you can take this force off because there is no need of this force. We have already resolved it. So you can take this off. Instead of this force, I have 6 Newtons here and I have 8 Newtons here. What next? Now I will see where this block is going to move. Obviously, this is kept on a surface. It is not going to move from the surface. So there is no motion along y-axis. So what is? There is no motion along y-axis. So I have to look at the forces along y-axis. One is the normal reaction n going upwards. The other one is 6 upwards. There is no motion along y-axis. So along y-axis, this particle is in equilibrium. Upward force is n, 6, n and 6, n plus 6. Downward force, as you can all see, along y-axis is 50. Downward force is 50. N plus 6 has to be 50. No motion along y-axis. The particle is in equilibrium along y-axis and becomes 44 newtons. That is our first answer. Do we get this? Can I have some raise hand that we understand this, sir? Along y-axis, nothing has changed. Upward forces shall be equal to downward forces. Only 5 people understand this. Not good enough. Manasa, Sashank, Bhojaraju, Venu, Navya, Veronica, some numbers starting with 3, Shruti, Sai Sarda, Reddy, Yashwant, Padmakan, Ganesh, Dinesh, Koli, Triveni, Sainath, Kevin, Karthik, Sashank, Yogeshwar, Sumant, Charita. Do you all understand this, beta? Okay. That was along y-axis. Things are also happening along x-axis. Now let us look at what is happening along x-axis. On the right hand side, I have 6 newtons. On the left hand side, I have 4 newtons. Now 6 is definitely not equal to 4. 6 here, 4 here. So there is a net force towards the positive direction of x-axis. So this body has to move along positive x-axis. Let me call the acceleration as a. Now I write the equation along x-axis. What is the equation along x-axis? I have to write it in this form. F net force is equal to mass into acceleration. When I talk about net force, 6 Newton is in this side, 6. If I call it positive, 4 will be negative. So 6 minus 4 will be equal to mass is 5. Acceleration is a. From here, I can get the value of A as 2 by 5 meter per second square, and that happens to be my answer, which is coming from equation along x axis, which is clearly marked in green. I get the value of normal reaction from equation along y-axis, which is clearly marked with blue. Do we understand this? Oh, yes, Santosh, 8 not 6. Why did I take 6? Sorry, genuine mistake. This is not, oh, wrong color. This is not 6 but 8. I did not see your messages. Sorry. So 8 minus 4 is equal to 5a. So instead of 2, you have 4 by 5. I think now the answer is correct. Thanks for correcting me. And thanks for being attentive that you see that I made a mistake. That is how this question has to be done. Do we understand this? How we have done this? Yes, Vaini, I think I have corrected myself. How many of you have understood this? Please raise hands. How I have done this? How many of you have understood this? Please raise your hands. Only 6 participants have understood this. 7, 8, 9, 10. It could be more. Let me find out. Manasa, Sashank, Yogeshwar, Venu, Navya. Let me know what can I do so that you are also able to understand this. Then some numbers starting with 3. Then Sai Sarda, Reddy Yashwant, Padmakant, Ganesh, Dinesh, Kohli, where are you beta? Triveni, Sainath, Kevin, Suman, Kartik, Charita. Are you there, everyone? So this is how you have to do it. Follow step by step. In the beginning, you might find this step confusing, what to do what. But if you keep on doing it in the same way, the method remains same. The method does not change. It will remain same like this. If you just keep on doing your stuff correctly, you should be able to solve questions correctly. Shall we move on to the next question? Everyone ready for this? Anyone ready for the next one? Okay. Here comes question number 2. And how does it look like? Let me try some figures. I have this and one. Okay. So I have an incline here, incline at an angle of 37 degrees. Then I have a body of mass. Let me change it to 10 kg. 10 kg kept on it. Obviously, the surface, the incline is smooth. There is no friction. 2 things you have to find out from here: the value of normal reaction and the acceleration of the body. It's easy to understand that this body is going to move where? Free to move. If you put it here like this on an inclined plane, in which direction is the body going to move? Everyone knows this, yes or no? We know this, yes or no? Where, in which direction this body is going to move? This body will definitely move down the incline with an acceleration a, yes or no? To find out that acceleration, I don't know, what do you mean by right to left? I mean, it will move down, right? It's in an inclined plane, so it will move down, right? Down the incline. Okay. You to find the value of this acceleration and you to find the normal reaction from the incline. Your time starts now. Let's see who gets the answer for this one. I hope all of you are trying. Vaini has given me the answer for normal reaction. She's too quick to give an answer. I'm afraid that that might not be correct, but still, she tries. And sometimes when you see a question and you feel it is very simple, sometimes you can make a stupid mistake. That is what that cost you your rank in the JEE mains, or for that matter in JEE advanced. Be patient. We are taking the first steps, baby steps. Now, once you are a baby, small baby, and you're taking baby steps, if you don't do it correctly, you will fall, you'll get injured. But that's how you learn. Baby steps. Anyone has done this? How many of you are trying? Can you just raise your hands and tell me that, sir, we are trying, else I will do it. If no one is trying, I'll do it. Karthik is trying, Vaini is trying, good. At least two are trying. What about the others? Only two people are trying the question. Three, Shruti comes here. Deepak also joins the party. Four, TNK 3010 also joins the party. 5, 6, 3006. Santosh also joins. 3007 also joins. Good, good. 8 people are trying. Janu is trying. What about the others? Only 9 people are trying. 3006. Okay. Try. Trying is more important than getting your answers better. Sumant, Anna, Shashank, Karthik, try. I'm not worried about the answer. I'm more worried about your trying. Saina, Triveni, Kevin, Ganesh, Padmakan. If you don't try, you will not get the answers. If you think that you can get the answer by copying what I'm doing, that will not serve you any good purpose. Navya, Venu, Bojraju, try. Trial is what that is important, not the answer part. Get the answer. Chalo. I think I've given you enough time. Let me now solve the question. First step, sketch, already there. Second step, isolate all bodies. Only one body, what to isolate. Number 3, draw free body diagram. Let us look at the forces acting on this. Gravity is always vertically downwards. mg, 100, 10 into 10. Then it is kept on an inclined plane. So normal reaction comes like this. N. Is there any other force acting on this body? No, there is no other force acting on this body. So the free body diagram is done. What do I do next? Choose convenient axes as x and y. What are the convenient axes here? You all know this. One axis would be like this. I will call this as y axis. And one axis would be like this. I will call it as x axis. Yes or no? Do we all agree on this? One axis is y axis, the other axis is x axis. Now, we all know that it is kept on an incline. It is not going to jump off. It is not going to jump off the incline. If it is not going to jump off the incline, the forces on y-axis must equate. What are the forces on y-axis? Here is N. What about here? Here there is nothing. Is there so? No, we have missed one step. This 100 Newton is not along x or y. It is going downward. But my x-axis and y-axis are not downward and horizontal. So I have to resolve this force, 100 Newton. Remember it. I've already told you how to resolve this 100 Newton. I've told you that this one becomes 100 cos 37 cos theta, 100 cos theta. Remember it, 100 into cos 37, 100 into cos 37 is 100 into 4 by 5. So this will become 80 Newton, which is nothing but 100 cos of 37. Do we understand this, everyone? This 80 is 100 cos of 37. Do we understand this, everyone? Then what about this one? The component which goes down the incline. This is 60, which is nothing but 100 sine 37. I'm not writing it because it will just make my diagram look bad. So I'm just not writing it. This is 60, 100 sine 37, and this is 80. As soon as I break it up into 60 and 80, my dear friends, bachon, I don't have to consider this force because this force is already done. So basically what I can do is cut it off. Just cut it off. This force is cut it. This force is cut. This force no longer exists now because I've already taken its components. Now, there is no motion along y-axis because the body is going to move along the x-axis. The upward force is N. The downward force now is 80. So along y-axis, what is my equation? Along y-axis, what is my equation? N is equal to 80 newtons. That is my equation along y-axis. Do you understand this? What remains is x-axis. Now, when I look at x-axis, what do I see? I see 60 on one side, but on the other side, there is nothing. On the other side, there is nothing. So this 60 must be the net force along x-axis. I have to apply the equation F net is equal to MA. There is nothing on the x-axis apart from 60. So 60 is equal to 10A. My A becomes 6 meter per second. That is the equation that I get from the x-axis in green. That gives me the acceleration of the body. From the y-axis in blue, I get the value of the normal reaction, which is 80. I'm done with both of my questions, and there goes the solution for this one. Do we understand this, everyone? Can I have some raised hand that we understand this? How I've done this? Only 5 people have understood this. What about the others? I'll repeat the process. Draw a sketch, already there. Free body diagram, drawn. 100 Newton downwards, normal reaction like this. Choose two convenient axes, y-axis like this, x-axis like this. Resolve 100 Newtons, 80 Newtons here, 100 cos 37, 60 Newtons here, 100 sin 37. There is no motion along y-axis, so n becomes 80. There is motion along x-axis, 60 becomes ma, 60 becomes 10a. Acceleration becomes 6 meter per second square. That is the answer that I was looking for. 8 people have understood this. I'm trying for others to come up. Manasa, Sashank, Bojaraju, Venu, Navya, Veronica, Numbers, Vijay, Yashwant, Sai Sarda, Shreya, Padmakant, Dinesh, Ganesh, Triveni, Kevin, Karthik, Sashank, Jogeshwar, Suman, Charita. Okay. People understand this, but they don't raise hands. Not a problem. Now, I can generalize this result. What do you mean by generalized result? Now, many a times in JEE especially, you might not be given the value of mass m. They will just simply tell you a body of mass m is kept. We call them alphanumeric questions, where only everything is given in terms of alphabets. No values are given. So instead of calling G as 10 meter per second square or 9.8, you will just write G as G, mass as m, length as L, distance as d. And these questions are very popular in JEE Advanced. Now, if I have to make a general result, now how does a general result look like? The general result will look like this. I will have an incline here. We'll just try to make a general result so that you can also understand that how a general result looks like. Now, this is an incline. The angle of inclination I had given was 37 degrees. Here it will be given as theta. The angle of inclination is theta. Then I have a block of mass m kept on this surface. Remember, this surface is frictionless. This surface is frictionless. We'll also see the case when friction comes. This surface is frictionless. Remember, as soon as you have a block kept, the surface is frictionless. You must remember the acceleration of this block. Acceleration of this block. Once you solve it, what result will you get? This will be mg. Normal reaction will go like this. This will be your y-axis. This will be your x-axis. You will resolve the force. This will be mg cos theta. This would be mg sin theta. You will make equation along y-axis. Equation along y-axis will give you normal is mg cos theta. Remember this. In this special case, normal becomes mg cos theta. It is the force. Now, once you write the equation along x-axis, the force along x-axis is mg sin theta. We have already discussed it. And that becomes equal to ma. See the beauty of this. M gets cancelled. And my simple answer becomes acceleration of this block is g times sin theta. G times sin theta is the acceleration of this block from this green thing. That becomes your general result. If you keep a block on an inclined plane, inclined at an angle of theta, your acceleration becomes g sin theta. You can check your result. You can check your result from the previous question. You can check your result from the previous question. Acceleration is g sin theta. G is 10. G is 10 in this case. G is always 10. Sin theta is sine of 37. Sine of 37 is 3 by 5. You multiply g by 3 by 5. You will get 6 as the answer. That is the answer you are getting. The value of mass m was given to you. Even if it was not given to you, the answer was still g sin theta, because acceleration of this block, which is kept on this surface, does not depend on mass. It is always equal to g sin theta. Do we understand this? What I have told you? Do we understand this better? What I have told you? Acceleration for this particular case will always be g sin theta. It does not depend on the mass. Whatever mass you keep, it will always remain g sin theta. Shall we move ahead? Okay. Now we have done question of body kept on a surface. What we have not done is question based on pulleys. So here comes the first question on pulley, and this machine is known as Atwood's machine. Atwood's simple machine. What is this Atwood's machine? Don't get confused by the terminology. A simple pulley hanging like this, having two masses. Now, instead of giving you the value of these masses, 5 kg, 10 kg, 20 kg, I'll give it in terms of alphabets. M1, mass 1. M2 mass 2. And I'll tell you that M1 is greater than M2, so that we understand how this block is going to move. M1 is greater than M2. How will the system move, anyone? M1 is greater than M2. How will the system move? If M1 is greater than M2, how does these two blocks move? Anyone? M1 moves downwards. Yes. M1 moves downwards and M2 moves upwards. Do we all understand this? M1 moves down, M2 moves up. Great. Now, listen to my words very carefully and try to relate with what we have already studied. If M1 moves down with an acceleration A, M1 moves down with an acceleration A, with what acceleration M2 will move? Will it be A or will it be something else? Remember what we have read about strings and pulleys and mass attached to the string, and all these things I have already given to you in your notes. Yes, Santosh, we just take inspiration from there. Instead of calling it minus A, Hannah, I'll call it A downwards and A upwards. Is it good? A downwards, A upwards. So that is the question. That is what you need to find out. You need to find out the acceleration of these two blocks, A, and the normal. There's no normal reaction here. There is tension in the string here. To find the value of tension in the string, how many strings you see here? I see two strings. One is definitely this string. The second can be this string. This could be a string, or this could be a rod, or this could be a hinge. It could be anything. Hanging like this, it could be a string, it could be a rod, it could be anything. So you have to find the tension in string 1, and whatever force, if it is a string, it will be tension. If it is a rod, it will be force inside the rod. Find the tension in the string 1 and the force in whatever is number 2. It could be a string, it could be a rod, it could be a hinge, it could be anything. How will you do it? I'll give you a minute to think about it. Answers are not important. Answers are the least important thing that I'm concerned about. I'm more concerned about you try it. If we are not dealing with stress and strain already, we'll come to that the later part of our journey. What I'm more concerned is if you encounter a question which you have not seen, how will you track it? Because in JEE, more often or not, you will encounter questions that you have not seen. So whenever you have a new question coming in front of you, what is your approach? That is what I want to see. Let me see how many are trying, first of all. No one is trying? Please raise your hands. All those gentlemen and ladies and girls and boys who are trying this question, only 4 people are trying it. Not good. Not good. You have to try. See something new, try it. Mansa, Venu, Sanjay, Navya, Veronica, all these old numbers starting with 3, Shreya, Sai Sarda, Yashwant, Padmakan, Ganesh, Dinesh, Kohli, Sainath, Yashwant, Karthik, Sashank, Jogeshwar, Suman, Charita, Tejasvi. See? Try. You may get the answer, you may not get the answer, least of my concerns. Viney has sent the message. I don't have the mobile with me. I'm sorry, I can't see it better. Mobile is gone. My kid has his test today, some oral test. So he has taken up that. I can't see it. Anyways, so many people trying. I'll give you a minute. T is equal to T1 M1G greater than M2G. I don't understand what you have written, Deepak. Try. Follow the steps. Try. Okay. I'll do my bit. Okay. First thing is draw a sketch. Sketch is already there. Second step, isolate all bodies. Bodies are well apart from each other. I don't need to waste time in isolating them. Question number 3. Step number 3, draw forces. Let us start with tension. Oops, wrong color. Okay. T, tension in the string. Same tension pulling the pulley. Same tension pulling the pulley. Same tension pulling the mass. If this is T and this is T, how much is this? All of us know it is 2T. 2T. Let us come to block number 1. Block number 1. Forces on block number 1. This is M1G. Downwards. T is upwards. T is upwards. M1G is downwards. There is no force on the x-axis. Don't need to worry about x-axis. There's only force on the y-axis. And see, we have already drawn that the acceleration is downwards. Acceleration is downwards. You have to apply Newton's second law on this block. How will you apply Newton's second law on this block? F net, this block. Newton's second law on this block. F net is equal to ma. Net force is equal to mass into acceleration. What is the net force? This block is going downwards. Remember, there is the downward force, M1G. There is an upward force, so it's subtracted, minus T. Downward minus upward is equal to M1A. That becomes the equation of this block from F net is equal to mg is equal to ma. M1G minus T equates M1A. Do we understand this? Can I have some raised hand that we understand this? All green. The left hand side, all green. Do we all believe in all green? How many people have understood this? Please raise your hands once again. Karthik has understood this. Only one student has understood this. Not good. Only 4, 5, 6. What I've done is I've applied F net is equal to MA, nothing else. And I've assumed that this is going down. It's not an assumption, it's a fact because M1 is greater. So it will go down, downwards. So M1G minus T is equal to MA. That was the equation coming from the mass M1. Now let us look at the mass M2. Let us draw the free body diagram. This will be the weight M2G going downwards. Now, how will I choose axis for this one? This will be vertical. This would be horizontal. No need for horizontal one because there is no force. Now look at the vertical one. Remember what I've assumed. I've assumed that this is going up. This is going up. Blue one going up. The upward force is T. Now let us try to make the equation for this block. Where will I make it? Okay, I'll make it here. The equation for this block will always be again F net is equal to MA. Remember, both the blocks are accelerating. Don't worry, doesn't change much. Both the blocks are accelerating. F net, to find the value of F net, the blue one, it is going up. What is the force in the upward direction? T. But don't forget, there is a force in the downward direction as well. To find net force, it is moving upwards. Upwards minus downwards here. In the left hand case, green one, it was downwards minus upwards because it was moving downwards. In this case, it is upwards minus downwards because it is moving upwards. T minus M2G will be equal to M2A. That becomes the equation for this block, which is block number 2, which is the lighter block, which is moving upwards. I may call this equation as equation number 1. I may call this equation as equation number 2. Two equations. Look at the unknowns here. What are the unknowns here? How many unknowns are here? T is an unknown. Number 1, T is an unknown. Acceleration is also an unknown, number 2. If you look at equation number 2, one unknown is t, the other unknown is a. There are only two unknowns, two equations. The equations can be solved, two unknowns, two equations, and you can get the value of tension and acceleration. Do we understand this? Can I have some reason that we understand this, sir? The next step is, how do you solve this? So I'll just write both the equations. How will I solve this equation? It is a simple mathematical expression. How do I solve this equation? I write the first equation, m1g minus t is equal to m1a. I write the second equation, t minus m2g is equal to m2a. I just add these two equations. I get m1g minus m2g is equal to m1 plus m2 times a. This implies that a becomes m1 minus m2 times g divided by m1 plus, that becomes my a. It might look very complicated here because it is written in the form of m1, m2, g, m1 plus m2. But if I put values here, it becomes very simple. You'll get an answer. Once you get the value of a, you can put this value of a in this equation or in this equation, and you can get the value of t from any of the above equations. Am I clear, everyone? How to solve this? Yes or no? So this is what we call as Atwood's machine, and this is the solution for the Atwood machine. You don't have to remember the answer for acceleration. With due practice, in due course of time, you would be able to tell the answer as larger mass minus smaller mass multiplied by g divided by the sum of the mass is the answer. Even if you don't remember it, you can always draw the free body diagram, draw the forces, and get your answer. The procedure remains same. If you can remember the answer, if you can remember the result, that would be an added advantage. If you don't remember it, no problem. Even I don't remember it. I can always find it out. Yes or no? Do we understand this? Can I now give you a question? So I'm giving you a question on simple Atwood's machine. This block is 4 kg, this block is 6 kg. Find the acceleration of both the blocks and the tension in the string. How many strings you see? You see a lower string, there could be an upper string. To get tension in one string, you should be able to get that tension in the other string. So the question comes to you now. What do you mean by the term minus 2g by 10 beta? See, you are just applying the formula without even understanding what you are applying. Think about it. If you can remember the result is good, but then understand what is happening here. Okay. Have all of you tried it? How many of you are trying it? Yes, well done. Only one student is trying it. Wine is definitely trying it. Reddy is also there. Deepak, only 4 people. Hanak is there now. Sainath is also there. Karthik has also come. What about the others? Tejasvi, Ajay, Shashank, Karthik. So many people are leaving the group. Maybe there's a problem with the network somewhere. Anyways, how do we do it? Let us try the simple way. Draw a sketch. Sketch is there. Sketch is there. Yes, I think it is quite better. Sketch is there. Draw the free body diagram. So I'm drawing the free body diagram. Tension T, tension T, tension T, tension T. This will be then 2T. This will be then 2T. Gravity is acting downwards, 40 newtons on this. Gravity is acting downwards, 60 newtons on this. We can all understand where this system is going to move. This is 60. This is heavier, so the system is going to move in this direction with an acceleration A in green, acceleration A. If this moves down, this has to move up with the same acceleration A. That will be done in blue. So blue thing is downward. Let us make the equations. Let us make the equations here. Let us make the equation here. Equation for this block. Equation for this block. What do you see is T is upwards. T is upwards. 40 is downwards. F net is equal to MA. T minus 40. T is upwards. 40 is downwards. Will be equal to 4A. That gets me the first equation of this one. Then I move on to the green one. Green one is moving down. 60 is down. T is upwards. What is the equation I get from this one? What is the equation I get from this one? 60 minus T is equal to 6A. You have both the equations, equation number 1 and equation number 2. You can solve this equation. If you add those two equations, add 1 and 2, you will get 60 minus 40 is equal to 6 plus 4A. That will give me A as 2 meter per second square. You can put the value of this A. You can put the value of this A in any of the equations. You would be getting the value of T. Once you get the value of T, the tension in the upward string will be twice of T. What is the value of T you are getting? Can anyone tell me what is the value of T? What is the value of T? Have you solved the equation? T will be 48 newtons. That is correct. T is 48 newtons. So this thing becomes 48 newtons. If this thing becomes 48 newtons, this becomes 96 newtons. Do we understand this, everyone? Can I have raised hands from everyone that we have understood the question, sir? Atwood's machine. Simple Atwood's machine. The question was based on a simple Atwood's machine. Do we understand this? Okay. Let me go on to the next question. Let us see. You can apply the same principle here. You must understand that all the questions will be done in a similar way. The only thing is they might look different. They might look different because they might have different configurations. but that must not now I have the configuration like this. How many strings you see now? I see there may be 2 or 3, depending on what you call the upper string. There is definitely a string here. There is definitely a string here. And this might be a string, or it might be a hinge, or it might be a rod. So to find the tension in all these things, forces in all these strings, and you have to find the acceleration. Remember, there are 3 blocks now. And to find the acceleration of all the 3 blocks, apply some common sense. You should be able to get the answer. I'll wait for you. Anyone knows where this system is going to move? Where is this system going to move? How is this system going to move? Anyone can tell me that? 6 kg block is going to move downwards. This block is going to move upwards. And this block is also going to move upwards. Now, can you tell me, if I call this acceleration as A, block 6 kg is moving with acceleration A downwards. Can you tell me with what acceleration block 1 kg will move? It has to move with the same acceleration. Remember, same magnitude, opposite direction. They are connected by the same string, so the tension is same. Acceleration is also same, so acceleration will be A. 1 and 3 are connected by a string, so they must move with the same acceleration. So all the 3 blocks move with the same acceleration, same magnitude. That means direction, one is going downward and the other 2 are moving upwards. Let's see who gets me the answers for this one. Acceleration is 2 meter per second square. That is correct. Anna, good one. Well done. Yes, Santosh, that is correct. How do you go about it? Draw a sketch. Sketch is there. Isolate all bodies. Let me try to solve it in this. If I need to isolate a body, I'll isolate it. Draw the free body diagram. How do I go about free body diagram? Let me call the tension here as T1, T1, T1. If these two are T1, this one becomes 2 times T1, 2 times T1. This is upwards T1. Now this is a different string, so T2, T2. I've drawn all the tensions to begin with. Let me now start with the rightmost block. The only other force acting on this block is 6G, mg downwards. As soon as I draw the free body diagram, I must be able to write the equation for this block. 60 downwards, T1 upwards, and it is moving downwards. Can anyone tell me what will be the equation for this block? Can anyone tell me what will be the equation for this block? It is moving downwards. 60 is downwards. 60 minus T1 is equal to MA 6A. That becomes the equation of the first block in blue. I hope everyone is there with me on this one. Yes or no? Yes or no? Okay. Now let us move on to the third block. This one. T2 is upwards. 30, 3G, mg is downwards. Understand how it is moving. It is moving upwards, green one. T2 is upwards, 30 is downwards. Then I have the equation for this block. T2 is upwards, 30 is downwards, acceleration is upwards. What will be the equation for this block? Anyone? What will be the equation for this block? Anyone? T2 upwards, yes, Santosh, minus 30 downwards is equal to MA. M is 3A. This is the equation I got in green. Let me name the equations. This is, let us say, equation number 1. Let us say this is equation number 2. The only thing left, now see, look at the number of unknowns and look at the number of equations you have. I will give you the idea that something is missing. One unknown, two unknown, three unknown, three unknowns, but the number of equations are only 2. That means we have missed something. What I've missed? I've drawn everything. What have I missed? I've drawn the equation of, I've written the equation of 6 kg block. I've written the equation of 3 kg block. Yes, I've missed this gentleman, the yellow one, looking small but doing a lot of things. Now, if I try to draw the diagram of this gentleman in the same diagram, the diagram will look fuzzy. So what I'll take, I'll just take it outside. Just take it outside. Just bring this block here. This is 1 kg block. I'm just isolating this so that the diagram doesn't look bad. What are the forces acting on it? T1 is upwards. T2, one force is downwards. Remember, this block also has a weight, mass. mg 10 is downwards. Now remember the yellow gentleman. Acceleration is upwards. So let me draw that acceleration also. Acceleration is upwards. Acceleration is upwards. Ting, 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 ting. T1 is upwards. T2 and 10 are downwards. Can anyone tell me what will be the equation of this block? What will be the equation of this block? Acceleration is upwards. T2 is downwards. 10 is downwards. T1 minus 10 minus T2 is equal to 1A. That becomes the equation for this block. Yes or no? Do we understand this? Yes or no? This becomes my equation number 3. Once you get equation number 1, 2, and 3, the problem in physics is done. The rest is maths. How you solve it? The easiest way of solving it is add 1, 2, and 3. Once you add 1, 2, and 3, T1 and T2 will get cancelled. Whatever remains will be 60 minus 30 minus 10 on the left hand side. What remains on the right hand side is 6 plus 3 plus 1A. From here, you will get the value of A as 2 meter per second square. As soon as you get the value of A, you can substitute it, put it in this equation. You will get the value of T2. Put it in this equation. You will get the value of T1. Can anyone tell me what is the value of T2 and T1? What is the value of T2 and T1? T2 is 36. That is correct. T2 is 36. The green one, green Hulk. What about T1? What about T1, beta? T1 is 48, the blue Hulk, and we are there with our answers. As soon as I have T1 as 48, I can get the value of this double times the blue hull, and that will become 96. And those are the answers that I was looking for. Can I have some raise hand that we understand what I have discussed today? Can I have some raise hands? No one understands this? Okay, 10 people have understood it. This is a homework question for everyone. I have created this small setup, changed something. Instead of both the blocks hanging, one is kept on a surface, the other one is hanging. What are the things I need to know in this? The normal reaction from ground, obviously on this block, the tension in the string, obviously this string, and the acceleration of the block. How is this system going to move? I think everyone knows it. How will the system move? Can anyone tell me? How will the system move? Can anyone tell me? This block is going to go downwards, and this block is going to go rightwards. Solve this question, try it. We'll look at the solution in the next class. Tomorrow you have your test. Portion remains same, motion in 2D. We'll get questions on that. See, again, always tell you, in a test, except you should always expect all questions to come. You should not never ask me what is the portion of the test, sir. In test, what would be asked is what we have done, up till what we have done. And normally the test is lagging a bit behind the course so that you keep in flow with what we had done. Yes, Shruti, what did you not understand? The previous question, this one? Okay, I'll come back to you. Let me say bye to all of those students who are leaving us. Bye bye. I'll meet you on Monday.